we did measure blood pH. Let me just get back to this. So when you do see this increase in blood PCO2, you see pH, pretend this line is pH, you see it come down, and it'll drop, right? And then as this animal is able to accumulate bicarbonate, so they have different ion exchanges in the gills, you'll see pH start to recover over 72 hours. And so that's why I look at 72 hours, is because that's how long it takes for this animal to acid-base compensate. And so I originally thought that you'd see blood stress indicators increase as pH dropped, and then as compensation occurs, you'd see it drop, sort of following that acid, the acid-base disturbance. But instead, we haven't really seen anything at all. But yeah, there is an acid-base problem that occurs, and then it's compensated for.
Mm-hmm. First of all, I'll comment that my dissertation is also full of negative results. It was the most interesting part. Can you go back? Do you have when you're really working at hypercapnia? So that you had whole experiments with hypercapnia, but then your graphs were saying hypoxia. So I want to make sure.
The behavior?
Yeah, I think it's behavior.
Okay. It was red. It should have been hypercapnia.
I think it should have been. I just wanted to confirm that there wasn't a mixed treatment there.
Oh, okay. One of these things.
Yeah, so it says right hypoxia, left hypoxia. Should that say hypercapnia? What?
Yeah. Oh, yeah. Sorry. I
forgot
you.
I just wanted to make sure there was not something I missed. Okay. In terms of the treatment. So, okay.
Yeah, I just did a bunch of copy paste. By the way. It's all good. Yeah, Manny.
Were all the experimental animals reared in hypercapnic conditions?
No. So I reared these all in the basement downstairs, and I was once in a while would throw the pH probe in there, and just to make sure it wasn't hypercapnic. But yeah, that is a good point, because I guess early exposure, or I guess repeated exposure, can lead to acclimation. So maybe these fish live in high CO2, and if I raise them in low CO2, maybe they'll be stressed out. But yeah, no, I check once in a while. Yeah, Alberto?
So this fish is endemic to Vietnam, right?
Yeah.
And that, like, its ability to sort of thrive in these ponds has led to this huge increase in production. Are there similar fish in other parts of the country that we might see a similar increase as demand increases?
So we can go back. There's a ton of species. Pangasius seems to be the fastest growing and probably the most appetizing to Westerners. So, meaning you probably don't want to buy a swamp eel at the store the way you'd buy a catfish fillet. So these are all everything fish species that are really popular in aquaculture, but aren't exported. And so because export is one of the main drivers of determining which fish are grown, this one looks the most delicious. I don't think you would buy this, or a fish called the snakehead. Over there, of course, they eat these things all the time, and they buy them and they farm them. But yeah, I don't expect to see any other of these animals appear on our local markets. Yeah.
So you said pangasius have sort of a modified gas bladder that allows them to store oxygen, like high evaporative.
Yeah, a lot.
Do you have any idea, like, given that, so we breathe through lungs, that's our oxygen exchange, fish feels that they have, this species has a modified gas bladder. Do you think there's any possibility that they're almost able to, like, stockpile oxygen in the gas bladder to essentially lengthen the amount of time they have to exchange that fresh oxygen?
So that's been proposed for, I guess, different types of gas bladders. So there's phycoclistic and physostomas, which means there's gas bladders that you can fill by gulping air, which these fish do. They swallow air and force it in the lungs. But there's gas bladders that really aren't attached to the environment, so they're sealed off. And the way that they fill those is through the root effect, in which they actually enrich those with oxygen. So they fill the gas bladder, they pressurize it with oxygen. This animal pangasius doesn't have that ability. Not only is it fill the gas by gulping air, so it's only going to be atmospheric air, but also they don't have a root effect. So they've lost this modulation of CO2 on the blood carrying capacity, or shifting the blood carrying capacity. And it might have to do with the fact that they always live in high CO2 environments. So if you have this root effect, which drops your oxygen carrying capacity, to offload oxygen, if you're living in a high CO2 environment and have a root effect, it's going to be chronically hampered. Your oxygen capacity is going to be chronically hampered. So they don't have that effect, and I don't think they would be able to enrich their gas bladder like other fish do. Yeah.
I'm only asking this because we had the job candidate earlier who was talking about endocrine systems and stuff. But your stress biomarkers that you were looking at seem like things that are pretty downstream effects associated with locomotor activity, right?
Mm-hmm.
And I'm wondering, just what was the rationale behind those particular things you're looking at? Do you think it's possible that they could be having a stress response that's just impacting different aspects of their physiology that isn't showing up in those markers?
Yeah, so that's one thing I thought about looking at is cortisol. Cortisol is another very standard indicator of stress. However, you look at stress, acute stress, it's great. But if you look at stress over long term, in terms of the order of days, I was reading that it's not the best. And the reason is because there's renal exhaustion. So cortisol just doesn't correlate well over long term. Sometimes it gets weaker, sometimes it gets stronger. So we didn't use that, but sort of these downstream indicators, I think, would catch if there's any changes upstream as well. So yeah, also cortisol is expensive, Jim's like. But yeah, I think we would be it's sort of indicators of what's happening upstream, and as well as indicators of what happened downstream as well. But of course, we should measure these things as well. Yeah.
Did you do any trials where you did combine hypoxia and hypercapnia, even just to see what the fish did?
Yeah, well, it's not for the behavior studies, but for the respiratory studies, we wanted to look at sort of what drives respiration, and so for that, we changed the oxygen, we changed the CO2, and then we did a combined effects to see sort of, I guess, what's really driving respiration in these animals and how is, oxygen CO2 exchange. But for the other experiments, no, we just tried to stick with one thing. But yeah, that would probably be future directions to look at how multiple stressors sort of interact and affect these animals.
I know you had previously you've shown something not here today, but in other committee meetings, you've shown those data where you actually did combine those effects in respiratory numbers. Mm-hmm. And I can't recall, like when you had hypercapnia and hypoxia, what they did.
So for Pangaceous, it really only responded to hypoxia, and you'd see increases in the amount of CO2 coming out just because it's breathing more oxygen. So it comes up, tries to consume oxygen at the same time, it's going to exhale. And so just by that, it was releasing more CO2. But I guess the sort of that study looked at a bunch of different animals and tried to compare what drives respiration. And it really looked, it correlated with amphibiousness and ability to, I guess, not breathe water. So fish tend to lose gill surface area as they tend to gain air breathing capacity. And so the more amphibious they got, or the less they were able to breathe water, the more CO2 they start, or the more they start relying on air breathing for not only oxygen but CO2 as well.
Like Aquarius.
Yeah, exactly. So if it's an amphibious fish like the weirdling catfish crawling on land, it's got to have a CO2 drive, and so it doesn't have that option of releasing CO2 into the water when it's running around land.
More questions? Okay. So what we'll do now is, if there's no more questions from the audience, the committee will stay here and we'll talk to Corey for a while, and then. Okay. All right, thank you.